Before actually I begin, I just want to say something. I'm gonna reference the video that I'm using myself. It's probably way better explained than how I'm explaining it. But if I like, if anything that I'm saying doesn't make sense, just refer to that video. um, okay, طيب, now we understand what a tree is and we know what these three things are. طب, what is a binary search tree and what makes it special? What makes it special is the way that it's arranged. It's arranged in a certain way. So let's look at this. Every single node, okay, all the elements, every node in its left subtree is less than it in value, okay? And every node in its right subtree is greater than it in value. Okay, let's begin with 15, and 15 is what we call the root node. Okay, my claim is every single one of these nodes here that exist in the left subtree of 15 are less than 15. So 8 is less than 15, 5 is less than 15, 11 is less than 15, 13, 6, and 2 are left are less than 15. Okay? Let's take 8's subtree. Every element in 8's left subtree, which is this, is less than 8. 5 is less than 8, 2 is less than 8, and 6 is less than 8. Okay? And every element to the in any node's right subtree is greater than that node. So everything in the right subtree of 15 has to be greater than 15. And in fact it is. You can pause and check. Everything in 24's right subtree is in fact greater than 24. Even, okay, everything here in the right subtree is greater than 24, even the things that are to the left of 28. Okay? تاني. مثلا احنا قلنا left is less, so everything here is less than 15, even the things that are to the right of any of 8 مثلا, because to the right means it's greater than the node. So in 8's right subtree, all of these are larger than 8, but if they exist in the left subtree of 15, they are less than 15. Okay, maybe I complicated it more than it needed to be, but basically, again, oops, what did I do? Okay, whatever. Okay, so again, every single thing here in the left subtree is less, no matter where it is in the left subtree, is like less than its root node, and that applies to all subtrees. Okay? Yes, let me think, what else do I need to say? Right, so if we somehow are able to maintain this structure, and we are able to maintain the storing of our elements here, احنا قلنا that ends up, like when we come to insert, delete, and find things, this actually storing them in this way, this ends up being much faster than our traditional containers like our linked lists and like our small mail arrays بتوعنا. Okay, as with any container, we must do we need to be able to do three things. We need to insert, okay, find, and delete. Okay, now let's start with inserting. Okay, if I want to insert into a tree, يعني مثلا, let's say I want to add a node مثلا, let's say I want to add 9, for example. If I need to add 9 into a tree that's already full like this, what I do is I start طبعا at the root. I'll think about this 1 second. Okay, yes, something very important I need to say. Anytime we insert a node, it must be inserted as a leaf. It will not, anytime I insert someone new, it's not gonna magically be here. It will always be inserted as a leaf. And remember, a leaf is a node that has no children. Okay? So when you come to insert, you start at the root. Okay? So I'm gonna start at 15, and I know that everything here is less than 15. Less than, and everything here is greater. Same for any node in any subtree. So 9 is less than 15. So I go down here, okay? And I'm thinking, is 9 greater than 8? It is. and anything greater is to the right. So I'm going down here. Okay, 11. Is 9 greater than 11? It's not, so I go to the left. So 9 is going to go here. Okay? I'm going to pause while I clean up our tree. Okay, let's take another example just to make sure it's solidified. Let's do something that's greater than 15 this time. Let's say I want to insert 16. Let's say I want to put in 16. If I start at my root, I ask, is 16 greater than 15? It is. So I'm going to take this path here. I'm going to use a different color because why not? Okay, so I'm going to take this path here. 16, so yeah. Now I'm at 24. I'm considering this subtree, and I'm doing the same algorithm on this subtree. I'm as if I'm ignoring everything else, and this, oops, and it's like this becomes my new tree that I'm considering. Maybe you're starting to see that this is recursion. You know what I mean? Like basically, I don't know. We'll see in code. We'll explain again. But like I'm redoing the same process with considering different things. But there's recursion happening here. It should make me think of recursion. Anyway, if I start and I do the exact same process, but now 24, I'm considering that to be my root. Okay. In code, you'll see like the recursion here, but I want you to watch out for that. Okay. Is 16 greater or less than 24? It is less than 24. So I'm going down this path. Okay? Is now 19 again, so I'm yeah, whatever the verb form of recursion is. So this is my new tree. Is 16 less or greater? It's less. So it goes to the left of 19. And in fact, 16 will be placed, it will be placed here to the left of 19. It will be 16. Okay? And it is a leaf, so it will be inserted as a leaf. Hopefully insertion makes sense. Let's look at finding. Okay, finding. Let's say I want to find مثلا node 5. Again, my algorithm goes, I start at the root, I ask myself, let's say I'm finding 5, I ask myself, is 5 less than or greater than 15? It's less than, and we said everything to the left is less and everything to the right is greater. Okay, so I'm considering now my left subtree because I have decided that 5 is less than 15. If I'm repeating the same process again, recursion, see? That should be how you're thinking. Again, now 8 is considered my root. I'm completely forgetting about this, and actually that's what makes it faster. Like what makes this faster than normal arrays, خلاص you've eliminated literally half, or like not half, there's like it's log or something, but you're eliminating like an entire thing that you know your thing isn't going to be found there, so you're really saving time. Okay? I'm starting here in 8. Is 5 less than 8? It is, so it must be to the left. Oh look, I found it, great. That's finding. Okay, next we need to do deleting. Yes, deleting. Okay. Okay, so deleting is probably like the most complicated part of it, but it's still quite simple conceptually. So when you delete, there's actually 3 cases. Is the node that I want to delete is it a leaf, such as is it 2 or 6 or 9, etc., or is it a node that has one child? Oh my god, there's a big mistake here. 19 is not a leaf anymore. 19 is not a leaf anymore. Okay. Is it a node that has only one child, like 19, like 28, like 19, like 28? Or is it a node that has 2 children, like 8 has 2 children? Remember the difference between child and subtree. Or مثلا what else? Or 5 has 2 children, and those children happen to be leaf nodes, whereas 8's 2 children happen not to be leaf nodes, they have their own children, in fact, they could have their own subtrees. Yeah. Let's begin with the case that I want to delete a leaf node. If I want to delete a leaf node, I'm going to remember like we did with find. I'm going to find the node I want to delete, and basically I'm just going to like make it null. If I want to delete 2, for example, خلاص, I'm just going to like delete it, aka in code make it null. But what if I want to delete a node that has 1 child? For example, what if I want to delete I want an example where something has 1 child but it has a tree attached to it. We don't have one in this tree, بس مش مشكلة. It's okay. Let's say I want to delete 28. Okay. I'm gonna find 28 like I usually do, and who I'll ask, is 28 greater than 15? It is, yes. Then it must be to the right. Is 28 greater than 24? It is, it must be to the right. Okay. So once I delete a node with 1 child, wait, let me think about this. Okay, I've figured out the best way to explain this. If I want to delete 28, remember, this is a node that only has 1 child. That child will come up and take the place of the parent. And again, the reason this works, like you might think, Ida, how could that work? Because 25 is in fact on the left side of 28. But when I move 25 to take its place, 25 will be on the right of 24. You might think that we messed something up, but remember the rule of a binary search tree is no matter what, every single thing in the right subtree of a node is greater. So even though 25 exists in the left subtree of 28, it exists more than that in the right subtree of 24, so we're not really ruining anything. So to delete 28, basically what I'm going to do is I'll just, 28 is a node that has 1 child. I'm literally going to go like this, goodbye. And then I'm going to move up my node. And if this had other children and it had subtrees, it's going to all go up with it. Actually, let's do an example of something, but I don't have anything that has 1 child. And like for example, if there were like many different things here and here and here, all of this would just go up with it. Okay? So if I have 2 children, it's different. Okay, if I want to delete a node with 2 children, we do something kind of different. Basically, let's take an example. And then like, instead of talking theory, let's take an example. Okay, let's say I want to delete مثلا node 8. Okay, I'm not gonna just just go like this, because I need something to take its place. Like a pointer, like 15 can't suddenly point to 2 things, but someone needs to come here instead of 8. Who is that? That is the next higher node. Mana, the next higher node, it means the number of all the numbers here that comes directly after 8. Okay? How do I find this number? I know that it's greater. Khalina, actually, let's make 8 come back. I know that this number is greater than 8 عشان it's the one that's, it's greater. I want the next greater node. Okay, since it's greater, I know I'm gonna find this node here. So I want the one directly after me. Where is that gonna be? It's gonna be the leftmost node starting at 11. Why does that work? Why does that work? It's because 11 is greater than 8. صح? And every single element in the subtree, the left subtree of 11, is less than 11, but since it exists in the right subtree of 8, it's greater than 8. Okay? But the one that is to the most left will always be the next greater node. But once we, let's implement this logic. Okay, I'm gonna go to the right of 8 because I know that the higher things, the things that are greater than 8, are in 8's right subtree, which is this thing. Okay, and then I'm gonna go to the leftmost thing عشان to see, like, basically what I do is, I want the next greater number, فهروح I'm gonna go to the right because that's like where I know to go, and it's 11. If I ask myself, can I do better than 11? Is there something closer to 8 than 11? How do I know? I go to the left of 11 because I know that that's where things less than 11 lie. So 9, I find 9. There's nothing to the left of 9. 9 is in fact who is going to take 8's place. 9 will be moved from here, and it's going to go here instead. Okay, let's do another example. Let's say I want to delete 15, the root. Okay, I need the thing that's directly greater than 15. Actually, no, let's not do 15 because I want an example where the next higher node isn't a consecutive digit. Our 8, we happened by coincidence, this tree happened to have 9. 5, 6, let's do مثلا. Let's say I want to delete 28. Let's say I want to delete 28, but there's no next higher node, so it's just going to be 25. Never mind, close. Let's say I want to delete 11. Sorry. Okay. I use my find logic and I find 11, and I need my next higher node, and I know that anything that's higher than me is in my right subtree. I find 13, I ask, can I do better? Maybe I could possibly find a 12. If I try to look for the 12, akid it's going to be to the left here, but it doesn't exist. The best I can do is 13. I remove 13 from here, and it takes my place over here. Okay. I just realized that 13, or 11, I guess, only had one child. So we basically we didn't. It was redundant to find the next higher child. But yeah, hopefully that algorithm makes sense. Okay, I guess we are indeed ready to start going into code. Again, before we go into code, the last thing I want to emphasize is that remember in our linked list, our node, we had nodes like this. One node contained data, and it contained a pointer to a node. In our tree, one node contains data, and it contains 2 pointers to a node. ده اسمه next, هنا we call them left and right. Okay? Yes. Hopefully your memory is fresh with the linked lists, so we can make progress with the code.